covers basic operation of the Craftek ISDN subscriber loop test set by Tektronics. To view this program, you should have an understanding of the basics of ISDN. We'll give you a quick refresher here, and then we'll show you how the Craftek functions in this environment, and we'll make several measurements with the Craftek. Refer to your Craftek user manual and reference guide for more detailed operational information. The Craftek is a portable handheld test set for use by the telephone craftspeople for installing, maintaining, and testing subscriber loops. The Craftek can be used as a standard phone or as a test set in various analog and digital technologies, such as POTS, EBS, commonly called P-phone, and ISDN. In POTS mode, the Craftek acts just like a plain old telephone. You can dial with pulses or with tones. In Enhanced Business Services mode, or P-phone mode, the Craftek can test Northern Telecom's EBS provisioned lines. You can use the set to simulate the primary set, several add-on sets, or simply monitor a line. ISDN mode is the focus of this program, so we won't be covering Craftek's POTS or P-phone capabilities. We will talk about the various switch types, operating modes and signaling formats, how to set Craftek up, and perform common tests. The Craftek we are using in this program contains firmware version 2.42. You can view the firmware version of your Craftek when you turn the unit on. ISDN is an acronym for Integrated Services Digital Network. It differs very much from the plain old telephone system, or POTS, in a couple of ways. The most notable difference is that ISDN is a digital network in comparison to POTS, which is analog. ISDN has a set of rules, or a protocol, so the ISDN equipment can make sense of this digital information. Another notable difference is in the equipment. There is quite a bit more to ISDN customer premise equipment than just a phone set. There is the power cube, the NT1, and the terminal equipment. Sometimes these are combined, or sometimes they are left separate, like you see here. The power cube is necessary because the power is supplied locally by the customer, instead of being supplied over the subscriber loop. Here is a block diagram of ISDN for basic rate service. Basic rate service offers two B channels and a D channel by time multiplexing over a single twisted pair. The B channels can be used for voice, data, video, or whatever the user wants, as long as the line is appropriately provisioned. The D channel is used for both user data and call control signaling. The main elements of the system are the central office, the twisted pair, the NT1 or network termination, the 4-wire pair, and finally the terminal equipment. Note the reference points ST and U. These reference points are used throughout this program. The ST interface refers to the 4-wire side of the NT1 device and connects the NT1 to the terminal equipment, such as a phone or computer. The U side is the 2-wire side and connects the NT1 device to the central office. The NT1, or Network Termination Type 1, is the device that physically terminates the line. It bridges the 2-wire U loop, used for transmit and receive, and the 4-wire ST loop, 2 each for transmit and receive. Sometimes the NT1 is built into another piece of equipment. For example, an ISDN telephone may contain both the NT1 and TE functions. On the other side of the NT1 is the ST interface. This is the 2-pair 4-wire interface between the TE and the NT1. The TE is the terminal equipment, which can be a phone, a computer, a fax machine, or a number of other items. It is the job of the TE to know how to converse with the NT1 using the proper ISDN protocols. We will see some of this later as we go through a typical setup configuration using the Craftek. Up to 8 TEs can be interfaced to a single NT1 in a multi-point configuration, all at the same time. Let's start by turning on the Craftek and stepping through some simple procedures to get dial tone. Then we can run through some of the more common tests, such as verifying that the service is turned up and is provisioned properly. We will also talk about tests such as NEBs and Phoebes, BERT, and D-channel packet. If you have a Craftek, you can follow along even if you are not connected to a line. Of course, you won't draw dial tone, but you can still follow along as we step through the menus. To turn on the Craftek, simply press the On button and it performs a self-test. The self-test takes approximately 15 seconds. At the completion of the self-test, the home screen is displayed, which displays a summary of the current Craftek settings. These settings will be the same as they were when the unit was last turned off. You can skip the self-test by pressing the 1 button while turning the unit on, or you can restore the factory default settings by pressing the 2 button while turning the unit on. After restoring the factory defaults, the Craftek will continue to go through the self-test routine. Now that the Craftek is turned on, we will configure it, plug in the line, and draw dial tone. There are typically 5 parameters that you must select to get dial tone. They are operating mode, switch type, NT1 type, SPID, and bearer service. These are the same steps as on your Getting Started card. To change the settings, we will be using the Setup key. As a shortcut, if you know which submenu you want, you can go directly to that submenu by pressing the Setup key followed by the submenu number. For example, to set the bearer service, press Setup 2, 8, and then press the 1 key to scroll through the various services. When using the Craftek to test ISDN, there are 3 possible modes of operation for the Craftek, and each requires a different means of connection. The most common mode is the TE plus NT1 mode, where Craftek emulates both the TE and NT1. In this case, you simply connect the line from the CO to the line port of the Craftek. If you are using the Craftek to emulate the NT1 only, then you connect the line from the CO to the line port of the Craftek and connect the line from the TE to the ST-NT1 port of the Craftek. Both connections are required because an NT1 must connect to both the CO and the TE. If you are using the Craftek in TE-only mode, then you only need one connection. Connect the line from the NT1 to the ST-TE port. Now let's set the operating mode. Press the Setup key followed by the number 1. This gives you the operating mode submenu. You can step through the various operating modes such as TE plus NT1, NT1 only, TE only, and other non-ISDN modes. When you see what you want, press Home. This selects the operating mode. Here we have selected the most common operating mode, TE plus NT1. Next, we will specify certain ISDN operating parameters. The first thing to set is the switch type. Press the Setup key followed by the number 2. You see another menu of the ISDN parameters. Select the switch type by pressing 1. Now you can scroll through the different switch types until you find the appropriate one. The various switch types are AT&T 5ESS, Northern Telecom Functional, Northern Telecom Stimulus, and National ISDN-1. Note that the National ISDN protocol can be implemented on any switch, AT&T's 5ESS, Northern Telecom's DMS, or Siemens switches. It is switch independent, so if you are on a national ISDN line, then the switch type that you will want to select is National ISDN-1. If you are on a 5ESS or DMS custom line, then you should select that particular switch type. When you have made your selection, press the Home key or the Setup key to exit. The switch type you selected appears on the home screen. The next item is NT1 type. The selections represent two types of line coding, AMI or 2B1Q. The type you encounter most frequently is 2B1Q. Although AMI is no longer being produced, you will still find a number of AMI format lines out there. To set the NT1 type, press Setup 2, 2. There are only two NT1 types to select, either AMI or 2B1Q. Press Home and verify the NT1 type on the home screen. Now let's plug the line into the Craftek. Typically, the user will be on the U side talking directly back to the central office. If you are at this reference point, plug into the line jack. After you connect the line and obtain U-Sync, there's just one more crucial ISDN parameter, the SPID. The SPID is the Service Profile Identifier that tells the switch who you are and what services you are authorized to use. Typically, a given DSL or digital subscriber loop has a SPID based on its primary directory number, although a line may have multiple SPIDs. You need to know this number before you can draw a dial tone, so be certain it's on your work order. Here are some typical formats. To get to the SPID entry screen, press Setup 2, 5. Enter the SPID and press the # to send it. If it is rejected, the Craftek will remain at the SPID entry screen and ask you to re-enter the SPID. Note that if you are not plugged in, the SPID will never be accepted. You need to be plugged in at this point. If the SPID is accepted, then the Craftek will jump back to the home screen. After entering the SPID, there may be another parameter to set. Since ISDN lines are provisioned for certain types of services, you will have to make sure that the correct bearer service has been set on the Craftek. In addition, you may need to select the proper B channel before you can complete a call. When you go off-hook, the TE device specifies the type of call it wants to make. The bearer service requested must be authorized for the call setup to be accepted. To select the service, press Setup 2, 8, and scroll through the selections. When the service that you want is displayed on the screen, press the Home key to select it. To select the channel, press Setup 2, 7, and scroll through the selections. The choices are Any, B1, and B2. If you select Any, the switch will pick one for you, but it may not pick the proper one if the channels are provisioned differently. Press Home to exit. Sometimes there are other ISDN parameters that may need to be set. For example, the directory number. These are all well documented in the Craftek manual. In summary, the 5 ISDN parameters you must set to obtain dial tone are operating mode, switch type, NT1 type, SPID, and bearer service. Once you have completed the 5 steps listed above, then you can hit the hook button and make the call. Let's take a moment to talk about the line status LEDs. Back when we first plugged the line into the Craftek, we got our first indication about the line status. There are 3 LEDs that give us this information. They are the hook LED, the T-Sync LED, and the U-Sync LED. The operating mode that you selected will determine which LEDs are used. If the operating mode you selected interfaces to the U-loop, then the U-Sync LED will give you the status of the U-loop. A red LED means that the U interface is enabled but not synchronized to the incoming data. An orange LED indicates that the U interface is synchronized to the incoming data, but communication between the terminal equipment and the CO is not ready. A green LED means that everything is OK on the U-loop. If the operating mode you selected interfaces to the ST loop, then the T-Sync LED will give you the status of the ST loop. A red LED means that the terminal equipment and NT1 are not in sync. A green LED indicates that the terminal equipment and NT1 are in sync. The hook LED gives you the indication of the off-hook request. A red LED means that the switch does not acknowledge the off-hook request. An orange LED indicates that the switch acknowledges the off-hook request but denies dial tone. In this case, a cause message will be generated on Craftek's display. A green LED indicates acknowledgement of the off-hook request and dial tone is available. Another Craftek feature that you may find useful is the volume control. To change the volume, press Setup, 2, 4. Press 1 to increase volume, 2 to decrease volume. Now that we have completed the setup of the Craftek, we are ready to make some measurements. Remember that ISDN is a digital network, so verifying ISDN lines is different than verifying analog POTS lines. In a digital line, information is sent using a bunch of ones and zeros. To verify the quality of digital lines, you must verify that the pattern of ones and zeros that is transmitted is the same pattern that is received. You must also verify that the lines are properly provisioned for the different kinds of services, such as voice, data, or packet. One way to verify that lines are provisioned properly is to try making the different kinds of calls. If the switch denies any of the call setup messages, then a cause message will let you know that the line is not provisioned for that service. There are two such performance tests that are part of the ISDN protocol. They are the NIBIs, near in-block errors, and FIBIs, far in-block errors. You can run the NIBIs and FIBIs tests on active ISDN lines. You don't need to have a call established because data is always being transmitted on active lines between the CO and NT1 in order to maintain sync and handle other maintenance functions. NIBIs and FIBIs are similar to a checksum error. It gives you an indication if the data is being transmitted correctly. To measure NIBIs, press Measure 0, 1. This will put you into the NIBIs measurement menu. Press the 1 key to set the time interval. Press the Measure button again, and this will initiate the NIBIs test. During this test, the display shows the total errors and errored seconds. The total errors is the accumulated number of NIBIs that occur over the selected interval. An errored second is a second in which at least one NIBI occurred. If multiple errors occur in a particular second, the total error count will be higher than the errored second count. FIBIs are the same as NIBIs, except that the errors reported are the errors received at the far end, in our case, the CO at the other end of the digital subscriber loop. The setup procedure for FIBIs is very similar to that of NIBIs. Note that FIBIs apply to 2B1Q lines only, so they are not available on AMI lines. So far, we've tested for simple errors. But to check for faithful reproduction of the data stream, you use a bit error rate test. This will measure the number of errors generated, end-to-end, on either B channel. For example, if a digital 1 is received where a digital 0 is expected, then the Craftek detects a bit error. The better the line quality, the fewer errors will be encountered. The bit error rate test can be run with the Craftek set in any of the following bearer services: speech, 3.1 kHz audio, 56 kilobits or 64 kilobits unrestricted data modes. You cannot run the bit error rate test with the Craftek set in D-channel packet mode. To run a bit error rate test, or BERT, you must first establish a call to a loopback circuit, such as a 108 test line, or to a unit capable of sending a standard bit pattern, such as another Craftek. Then go to the BERT menu by pressing Measure 1, 9. The Craftek will default to a predetermined bit rate depending on the bearer service. However, you have the option of manually selecting between 56 kilobits and 64 kilobits. You can set the bit rate by pressing the 2 key and then toggling between the two rates by pressing the 1 key. Press Measure again to go back to the BERT menu. Next, we set the time interval by pressing the 3 key. You can set the time anywhere from 1 second up to 24 hours. We'll set the time to 1 minute. To do this, we enter 00 hours and 01 minutes. Now we press the Measure key to start the test. If you don't have a call established, you will see an error message stating that you must have a call established to perform this test. The first screen that we see provides a quick overview of the status and results. This screen will tell you the data rate of the line that is being checked, if the test is running or if it is stopped, the elapsed time, and the BER, or bit error rate. At the bottom, you will also see how some keys are assigned. For example, the 3 key lets you go to the next screen. Step through the various screens to view other results reported by the Craftek. While running the BERT, the Craftek allows you to manually insert errors as a confidence check. Scroll through the various results screens until you see the Bit Errors screen. You can add one error by pressing the 2 key. Each time you press the 2 key, an error is sent, and you will be able to see the bit errors increment by 1 and also the errored seconds increment by 1. There are a lot of results to be viewed, but the most important one is bit error rate. All of these screens can be viewed while a test is running or after the test is completed. Here are the 3 steps for making a BERT once you have a call established. Set the bit rate, set the time to run the test, and view the various results. To further verify line quality, you can add some attenuation to the U-loop. This will reduce the signal strength and allow you to identify marginal lines. Attenuation can also be added to the ST loop if you are in the appropriate operating mode. To add attenuation on the U-loop, press Measure 03 and press the 1 key to add. Let's add 5 dB. You can add up to 42 dB. Press Home to exit. The final test that we will cover concerns D-channel packet. To run this test, we must set the Craftek's bearer service to D-channel packet. Press Setup to 8 and step through the selections until you see D-channel packet. Then you must establish a call to a loopback circuit or a device that will answer a D-channel packet call. To make the call, press the hook key just as you would when making any other call. Notice that you will not hear dial tone, but you will see a message at the bottom of the screen that tells you to dial. Punch in the telephone number and press the hook key to send. You will then see the hook LED turn green, indicating that the call was placed. If it turns orange, then there is another problem. For example, the line is not provisioned for D-channel packet. By making the D-channel packet call, you have verified that the line is provisioned for D-channel packet. Otherwise, the switch would have denied the call setup. You can further test the D-channel capabilities by sending the quick brown fox message. Go to the D-channel packet screen by pressing Measure to 0. Press the 1 key to start the transmission of the fox message. The display will show you the message being sent out, and it will also display the message that is coming back. This will verify that the line is provisioned for D-channel packet and that the packets are being transmitted through the system properly. We've shown you the procedure for setting up the Craftek, and we've made several measurements. Remember, there are 5 key parameters that must be set to draw dial tone. They are the operating mode, the switch type, the NT1 type, the SPID, and the bearer service. To help you remember these steps, the Getting Started card describes each step of the setup procedure. Keep your pocket reference card handy. On the front, it lists the various setups for the Craftek. On the back is a list of the 20 pre-programmed measurements that Craftek can perform. For information on the other measurements, refer to your operator's manual. If you have further questions, there are several sources for answers: the Getting Started card, the Pocket Reference card, the Reference Guide, the User's Manual, application notes from Tektronics, and for technical support, contact your local Tektronics representative or call the 800 number on the back of every instrument.